All right, we talked about using the Pythagorean theorem yesterday, and when we know two of the three sides of a right triangle, we can use the Pythagorean theorem to find the missing side. But we have some special cases, some special triangles, where we don't need to know two of the three sides. One of those special situations is the 45, 45, 90 degree triangle. So if we know that the degrees, we have a right triangle, that's 90 degrees, but if the other two degree members are both 45 degrees, then we can figure out what the three side lengths are by just knowing one of the sides. We don't need to know two, we can know just one. It says in a 45, 45, 90 triangle, the legs are congruent. What does it mean to be congruent? Oh, it means to be equal. So the two legs of the triangle are both going to be the same measurement. Okay, in this drawing it's S, they used a variable, but whatever length one of the legs is, the other length will be the same. And then it says the length of the hypotenuse is the square root of 2 times the length of the leg. So if the leg is a measure of S, then we would say S times the square root of 2 is the length of the hypotenuse. Okay, so we always have that same consistent relationship anytime we're dealing with a 45, 45, 90 triangle. So if I look at the examples here at the bottom of the page, I can see in triangle XYZ, I have a right triangle, and I've got 45 degrees in these corners, so it's going to fit that situation. The legs, remember, are here. The legs form the right angle. So the legs are going to be, it says, congruent. So if this measure is 7, this leg would also have to be 7. Okay, this is the hypotenuse down here, and to get the hypotenuse, we take it times the square root of 2. So we take the leg length, which was 7, and we multiply it times the square root of 2. And again, you're going to leave your answer in a radical form. Okay, if I look at the next triangle over here, I've got triangle KLJ. What I'm given is I'm given the hypotenuse. I know that the hypotenuse is 12 square root of 2. I want to know what the legs are. What was that measurement to get 12 square root of 2 for the hypotenuse? And some of you might know this right off the bat, but we're going to kind of go backwards. When we knew the leg, we multiplied by the square root of 2 to get the hypotenuse. So when we know the hypotenuse and we want to go back, we're going to actually take that and we're going to divide it by the square root of 2. We're going to undo that part. And so the square root of 2's in the numerator and the denominator are going to cancel each other out, and the legs would be 12, and the legs are congruent. Whatever one leg is, the other leg will be the same. Okay, and then we've got one more example of a 45, 45, 90 triangle. Okay, I've got the hypotenuse here as 9. Okay, if you think of the one up above, when we had the hypotenuse, we divided it by the square root of 2. Now, in math, and you have not seen this before, but in math, we cannot leave a radical in the bottom of a fraction. And in order to take care of that, we're going to multiply the bottom by itself. Okay, so when I take 9 times the square root of 2, I just get 9 square roots of 2. And in the bottom here, the square root of 2 times the square root of 2 is the square root of 4. Now we know what the square root of 4 is. What's the value for the square root of 4? Okay, that's going to be 2. I'm sorry, not a 7. That's going to be a 2. So we get 9 square root of 2 over 2, and we're going to leave our answer that way. Okay, those are the lengths of the two legs. That would be the length of the hypotenuse. That's a 45, 45, 90 triangle. Okay, we're going to continue here. The second special triangle that we have is a 30, 60, 90 triangle. So again, we still have a right triangle. Okay, we've got a right angle here, but now we've got 30 degrees and we have 60 degrees. It says in a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the short leg. Okay, so the shorter leg is going to be across from the smallest angle. So when you look at your angle measurements, this is only 30 degrees. That's the smallest angle between 30, 90, and 60. So if it's the smallest angle, S is the smallest side. The hypotenuse is going to be twice that amount. So you just have to double that. Whatever value you have down here, you're going to take it times 2. In this case, since the shorter leg has been labeled with S, the hypotenuse would be 2 times S. The length of the long leg is the square root of 3. So I'm going to take the shorter leg, and I'm going to take it times the square root of 3. This is the longer leg because it's across from the bigger angle. Okay, 60 is the bigger angle, so it has to be the longer leg. I just take whatever the short leg distance is times the square root of 3. And again, I'm going to leave it in that radical form. Okay, so let's look at some examples here. Okay, we have our 30, 60, 90 triangle here, and I'm given which leg? That's one of the legs. Is that the shorter leg or is that the longer leg? Okay, that is the shorter leg because it's across from the smallest angle. So in order to get the hypotenuse from that short leg, I take it times 2. So I do 6 times 2, or that's going to be 12. And to go from the shorter leg to the longer leg, I take that short leg and I multiply it times the square root of 3. And we're going to leave our answers in radical form. So just leave it 6 square root of 3. On the example up here, is that, what am I given? Which leg of the triangle am I given? Is that the shorter leg or is that the longer leg? Okay, if you look across, that's the larger angle, so that's the longer leg. So if I'm going to go backwards from the longer leg to the shorter leg, I'm going to just take that and divide by the square root of 3. So if I take 9 square root of 3 and I divide it by the square root of 3, those are going to cancel out and I'd be left with just 9. So the short leg is 9 units. And to go from the short leg to the hypotenuse, we double it. So this is going to be 9 times 2, or 18. Okay, these bottom two are a little more challenging. Okay, so this would be my right angle, so the value that I'm given is the hypotenuse. Okay, so how does the hypotenuse, and then you can kind of tell by looking at it that this is the shorter leg right here. So we've been going from the shorter leg and taking it times 2 to get the hypotenuse. What if I go the other way? What would I have to do to the hypotenuse to get back to the shorter leg? Okay, I would have to divide it by 2. I'd have to come up with 10 there. And then once I know the short leg, I can just take that short leg times the square root of 3 to get the longer leg. Okay, last example, this is the long leg that I'm given. Okay, just by sight, you can tell that that's the longer leg than this one over here. So how do we go from the longer leg back to the shorter leg? Well, we divided by the square root of 3. Okay, here we had the longer leg and we wanted to go to the short leg. We divide by the square root of 3. So when I take this 4 and I divide it by the square root of 3, okay, we saw that on the previous triangle. We can't leave a radical in the bottom of this fraction. So I'm going to take this times the square root of 3. So this is going to be 4 square root of 3 over the square root of 9. And we know what the square root of 9 is. The square root of 9 is 3. Okay, these 3's will not cancel each other out because one is under a radical and the other is not. Okay, so this leg is going to be 4 square root of 3 over 3. We just leave it in radical form. And then how do we go from the short leg to the hypotenuse? Here's the short leg to the hypotenuse. We're just going to double it. So I'm going to take this value and I'm going to take it times 2. Well, when I take that times 2, I get 8 square root of 3 over 3. This is like 2 over 1. So the denominator, 3 times 1 is still 3. Here you can only multiply the numbers that aren't under a radical. So 4 times 2 is 8, and we just leave the square root of 3. So my short leg is 4 square root of 3 over 3. And my hypotenuse is 8 square root of 3 over 3. Okay, that's how these special triangles work. There's really no formula. It's more memorizing the relationship between the shorter leg and the longer leg and the hypotenuse for the 30, 60, 90 triangle, and the legs and the hypotenuse for the 45, 45, 90. These relationships only work for those two special situations.